Today in our class, I need to explain the combination of capacitors and we have to find equivalent capacitance. Already we are continuing our electric charges and fields and also capacitance, okay, and electric potential. So these are our continuation chapters in this session. The most important topic it is how we can find the equivalent capacitance in various combination of capacitors. Already we seen that the series and parallel combination of capacitors. In series combination, what is the constant factor? In parallel combination, what is the constant factor? Which is the variable factor? So these type of terms will be very important to remember to solve the different and difficult construction of the capacitors. Okay. So let us start our class with the simple to complex. Simple to complex, which is important for NEET and JEE. Okay, so you should focus on my lesson and please subscribe my channel and share to your friends. Let us start our topic. Equivalent capacitance. Equivalent capacitance. So how we can find the equivalent capacitance? So there are two combinations are there. The first combination, it is the series combination. Already we discussed very well, series combination. So in the series combination, just you have to remember, if two capacitors are in series, this is the series combination. Okay, in this series combination, the charge Q, it is equal Q1, it is equal Q2, it is equal to Q here. So this is the capacitance of C1 and capacitance of C2. So this is the second capacitor capacitance and C1 is the first capacitor capacitance. So here in series combination, the charge on any capacitor is equal, it is constant, right? The potential V is equal V1 plus V2. So here potential is variable. You have to remember. Okay, right? And coming to the resultant capacitance should be, it is C effective or resultant capacitance or equivalent capacitance, it is equal. Whereas if two capacitors are there, it is C1 C2 by C1 plus C2 here, or 1 by C effective, it is equal to 1 by C1 plus 1 by C2 here. So this is the effective capacitance in series combination. You have to remember that. And now coming to the parallel combination. If there are two capacitors are connected parallel to each other, this is the A and B. So this is the capacity C1 and the capacity C2. And at this, the potential V is equal to V1, it is equal to V2 here. So potential is constant here. But which is the variable here? The charge is variable here. So here charge Q, it is equal to Q1 plus Q2. It is variable. The charge is variable. So what is the effective capacitance here? C effective, it is equal to C1 plus C2 here. C1 plus C2. So this is the parallel combination and this is the series combination, you have to remember. Right? Let us see some examples of circuits, how we can find the equivalent capacitance in different circuits. Let us see. First, suppose here there is a capacitor, here there is another capacitor, and these three are the capacitors. It has 2 microfarad, it has 2 microfarad capacitance and 2 microfarad capacitance connected to the one battery which has This has 6 volts of battery, right? Find energy stored in, so this is the A and B. Find energy stored between A and B, So let us UAB, it is how much? UAB, it is how much? So the energy stored in the capacitor, you have to write that U, it is equal of CV square, because of this is the potential and this is the capacitance. This is the formula you have to find. So where you have to find the capacitance, it is the C effective capacitance. C effective. How we can find the effective capacitance here? C effective, it is equal. So here these 3 capacitors are in series combination, right? In the series combination, already you seen that the potential is changes, but the charge is on the capacitors. Every capacitor is same here. Okay. Let us see. 1 by C effective, it is equal to 1 by C1 plus 1 by C2 plus 1 by C3 here. It is 1 by 2 plus 1 by 2 plus 1 by C2. It is 3 by 2. 1 by C effective, it is equal 3 by 2. C effective, it is equal reciprocal reverse 2 by 3. 2 by 3 microfarad. So what is our aim to have to find that? You have to find the energy stored between A and B terminals. So UAB, it is equal 1 by 2, C effective, it is 2 by 3 into V square. How much potential is here? 6 volts. 6 into 6 square. And 2 2s are 2 1s are 2, cancel out, 3 2s are 2 into 6, UAB, it is equal, how much it is? 12 volts. 12 volts of energy, 12 joules of energy. 12 joules of energy is stored in between A and B. Okay? Right? So this is the energy stored in between A and B. Right. Let us see one more example. If three capacitors are connected, so this is the one of the capacitor and this is the another capacitor and this is one more capacitor, are connected to a battery of here 6 volts. Then find, this is 2 microfarad and this is 2 microfarad and this is 2 microfarad. Find the energy stored in the A and B. The energy stored UAB, it is equal to 1 by 2 CV square. So C, it is nothing. C effective. How we can find C effective here? So at C1, C2, C3, these 3 capacitors are connected in parallel combination. Therefore, C effective in parallel combination, it is 2 plus 2 plus 2, it is equal 6 microfarad. 6 microfarad, right? So then the energy between AB, it is equal 1 by 2 C effective into V square. It is C effective, it is equal 6 microfarad and V square, it is equal 36. And 2, how much it is? 3 36, 90 and 112. 108 joules. So this is the energy stored in the between A and B. Energy stored between A and B. So how we can find the effective capacitance should be 6 microfarad and our voltage should be, potential should be 6 volts, that is 636. We have to find that on 108 joules, right? And see one more example. this is a capacitor, and this is a capacitor. This is 2 microfarad and 4 microfarad. One more capacitor. This is another capacitor having 4 microfarad, having 2 microfarad, right? So here there is a pointer, right? So this is point A and this is point B. Find equivalent capacitance between A and B. Okay, so let us find. So let us see. These two are connected in parallel. Right? So these two are connected in parallel. For example, this is first plate and first plate, second plate and second plate. First plate will be first plate connected to the A. Second plate is connected to the this one. Okay, so this is the parallel combination. So if two are parallel combination, so then for example let it be C1 here. C1. So C1 it is equal, where it is 2 plus 4 microfarad is 6 microfarad. So let it be here the effective capacitance C2 here. These two are also in parallel. It is 6 microfarad. And 4 plus 2 it is also 6 microfarad. So here C2 is also 4 plus 2. It is 6 microfarad. So now C1 and C2. So here there is a C1 capacitor here and here C2 capacitor. These two are connected. It means these two are in series combination. So this is A. Okay. What you have to write that? So this is the C1 and this is the C2. This is C1, this is C2. 6 microfarad and 6 microfarad. This is A and this is B. So now these two are in series combination. It is 1 by C effective is equal 1 by 6 plus 1 by 6 here. 6 is LCM, 2 by 6. It is 1 by 3, 1 by C effective, right? So effective capacitance C effective it is equal to 3 microfarad. What is the effective capacitance in this combination? That is 3 microfarad. How we can find that? At first these two capacitors are in parallel combination. Okay, so this is parallel, right? And again these two capacitors are in parallel, right? So that capacitor should be mentioned by C1 and mentioned by C2. So these two are in now series combination. So this is series, right? So let us find. It is effective capacitance is 3 microfarad. Okay. Note it. Let us see one more. One more it is. This is a capacitor and this is another capacitor, and we have to write that this is another capacitor. So this is A and this is B. This is 1 microfarad and 3 microfarad and 6 microfarad. Find equivalent capacitance between A and B. So let us find CAB, how much? Equivalent capacitance CAB, how much? Let us see. So these two capacitors are in series combination. So in series combination, for the first two capacitors they are in series combination. So therefore 1 by C effective it is equal to 1 by 1 plus at right? First we have to write 1 by C1 plus 1 by C1 plus 1 by C2, let it be. It is C1 here, it is C2 here, it is C3 here. Right? It is equal to 1 by 1 plus 1 by 3. It is equal to 1 plus 3 plus 3 plus 1 by 3. It is equal to 4 by 3. 1 by C effective it is equal 4 by 3. C effective it is equal 3 by 4 microfarad. Right? 3 by 4 microfarad. Now this 3 by 4 microfarad is, so this is 3 by 4 microfarad. Here 3 by 4 microfarad. Okay. This is, let it be C4. Let it be C4. And this is the A here. And here another capacitor is there. This is B and this is A. So this is how much here? C3. It is 6 microfarad. Let us, these two are in parallel combination. So let us parallel combination. In the parallel combination you have to find that effective capacitance, it is equal 3 by 4 plus 6. C is equal C1 plus C2. Right? So it is equal 3 plus 24 by 4. It is equal 27 by 4. It is equal C effective. Right? So then how can I write that? 6.8 microfarad here. 6.8 microfarad. So the effective capacitance CAB it is equal 6.8 microfarad, or it is equal how much? 27 by 4 microfarad. So this is the process you have to find equivalent capacitance in different circuits. Okay, if there is a series combination, so let us, in series combination, 1 by C, 1 by series CS, let it be 1 by CS, it is equal 1 by C1 plus 1 by C2. If there is parallel combination, then you have to find the equivalent capacitance as CP, it is equal C1 plus C2. So these two are very, very important formulas you have to remember to find any circuit. The basic formulas you have to remember that. Right? Let us see one more example. Is if here there is a capacitor, it is 2 microfarad, and one more capacitor, it is 12 microfarad, right? So here there is another capacitor which is connected to the first capacitor. This is point A. This is having the capacitance, how much it is? 2 microfarad. And here there is a capacitor, right? This is point B, right? It is 2 microfarad. Okay, find equivalent capacitance between A and B. So here there are options are there. A is 28 by 9, B 4, C 5, D 8. So these are all in microfarad. Okay, let us find. Try for it. So here there are 1, 2, 3, 4 capacitors are there. Let us first we have to see this capacitor and this capacitor. So these two are in. So this is the first end and this is the second end. First end, second end of the capacitor. Okay. The second end of the first capacitor is connected to the first end of the second capacitor, and second end will be connected to the first end. So now these two are in. How we can write that? So the re-diagram for these two, it is the first capacitor, first end, second end, and also this is connected to the first end of the second capacitor, and second end should be connected to this one. So here these two capacitors are in, what is that? Parallel combination. right? So here 2 microfarad, 2 microfarad are in parallel. Hence C effective it is equal, you can write 2 plus 2, it is equal 4 microfarad. Okay, C effective it is the 4 microfarad. Now here there is a 4 microfarad capacitor here. What is the diagram here? So this is A, and here this is 4 microfarad, and here this is 12 microfarad. Already here it is, and this is the B, and here there is a, how much here? 2 microfarad, and it is connected this one, right? So this is the diagram here. Now these two capacitors are in series combination, right? So now 4 microfarad, 12 microfarad in series, right? In series combination 1 by C, yes, it is equal 1 by C1 plus 1 by C2 here. It is 12 is the LCM, 3 4s are 112 is, it is 4 by 12, it is 1 by 3, 1 by CS. CS it is equal 3 microfarad. CS is equal 3 microfarad. Now here there is a 3 microfarad. The diagram it is, how you can write the diagram? This is A, and there is 3 microfarad, and this is B, and there is how much here? 2 microfarad, right? These two are in parallel combination. Now 3 microfarad and 2 microfarad in parallel. So whereas in parallel combination Cp is equal how much? 3 plus 2. Here 3 plus 2, it is equal 5 microfarad, right? So the option it is C. Option C is the right answer here. So let us simple, you have to imagine how they are connected. So which is possible to make the circuit. Okay. So this is the break-even formula. So one part is break and the other part is find out. So that is, you have to draw this, right? So here this is the effective capacitance in parallel combination. How much it is? 5 microfarad. At first you have to see these two capacitors, and this will be make at the effective capacitance is here, and these two are in series combination. By the series combination, their effective capacitance is here, and this one is parallel. So that is effective capacitance in parallel. The total A and B, it is how much? 5 microfarad here, right? Let us see one more question. So the practice is very important for doing the numericals in circuits. So whenever you have to practice more in the circuits, then only you have to get the better idea. And here there is a capacitor. There are 3 capacitors are there. Here this is point A, this is end B. So this is the connection, and this is the earthing, right? So now find here each capacitance is 45 microfarad. Then find equivalent capacitance between A and B. Now we have to find CAB. How much CAB? How much? Right? So let us see. Here there is a point A, there is a point B. Okay. Let us observe from point A to this connection. There is no devices. Let this is also A. If there is, it is A, then this can be the point here. This is also A, right? If it is a B, so because of here there is no connections between these 2 points, this is the B. And if it is a B, and this can be the B, right? So now the rediagram it is, this is the point A, this is the point B. There is a capacitor from between A to B. So this is the end A and this is the end B. This is the end of the first capacitor, end of the first capacitor. Okay, from A to B there is a capacitor. Here A to B there is a capacitor right at B. First capacitor. Coming to the second capacitor, the first end is B, second end is A. So this is the first end is B and the second end is A, right? And one more capacitor is there, that is third capacitor. The first end is A and the second end is B. First end is A and the second end is connected to the B. So here this is C1 and this is C2 and this is C3 here. So C1, C2, C3 are three capacitors are connected to the parallel combination. Let us find. So here each capacitor having the 45 microfarad. So then what is the resultant? So these are in parallel combination. The effectivity is equal, C effectivity is equal C plus C. It is equal 3C. C it is equal 45. 3 into 45 it is equal 135 microfarad here. So this is the effective capacitance in this type of questions. Very, very important model here. How we can find this? So let us. So this is the point A and this is the earthing of the connection, and this may be a point A because of here there is no connections between it. The potential will not be changed. The potential is remains same here. Here at that point A and also here A. Here at that point A, B is also B. Okay. So similarly, if it is a B, this connection through how much? It is B. If it is A, this connection through how much? A. So between A and B there is a capacitor, and B and A the another capacitor, B to A. The other capacitor A to B, A to B. So here three capacitors are connected in parallel combination. So let us parallel. You have to find the effective capacitance is 135 microfarad. Clear? Here there is a capacitor and one more capacitor it is, and the another capacitor. So here this is the point A and point B. There is a battery here which is connected. It is 12 volts of battery, plus and minus. So this is 2 microfarad, 4 microfarad, 6 microfarad. Find charge on each capacitor. Charge on each capacitor here. So there are options are. So let us write the options. It is where it is 2. The options are 6 microfarad and 3 microfarad and 2 microfarad. Similarly, it is 24, it is 48, it is 72, and C it is 18, 6 and 6, and D it is the charge on capacitor. It is so 24, 24, 24. So now let us find the charge on each capacitor is here. How much? The charge on each capacitor, right? So this is the parallel combination of capacitor. This is the parallel combination. Due to the parallel combination, so the charge is potentially same here. Potential is same. In a parallel combination, potential is same, but the charge is unchanged. So charge is not same, that is variable. So Q is equal to Q1 plus Q2 plus Q3 here. So how we can find the charge on the each capacitor? Charge it is equal, Q is equal CV. Capacity into potential, capacity into potential. For suppose first capacitor, this is 7, it has Q1 charge, it has Q2 charge, it has Q3 charge. So Q1 it is equal charge into potential. Charge, how much charge it is? So it is charge, it is equal 12 volts, already given that. So how much capacitance here? C, it is the 2 microfarad into V, it is the 12 volts. It is 24 microcoulomb here, microcoulombs, right? And Q2 it is equal from CB. C, it is nothing but 4 microfarad into potential, it is 12. It is equal 48 microcoulomb. And Q3 it is how much? 6 into 12, it is the 72 microcoulomb here. So this is the option you have to choose, right? If 3 capacitors are connected in parallel by the 12 volts of battery potential, and then find charge on each capacitance, each capacitor, charge on each capacitor. So then you have to find, this is the method you have to find. Charge is equal capacitance into potential, right? And now one more it is, if there are 2 capacitors are there, if 2 capacitors, or suppose there is a capacitor 3 microfarad and another capacitor 4 microfarad are connected by the potential that is 6 volts. Find charge on each capacitor, charge on each capacitor, charge on each capacitor. How we can find the charge on each capacitor? Okay, let us see. Here the 2 capacitors are in series combination. In a series combination, charge is in a series, charge is same. Charge is same here, right? So let us, these 2 capacitors are in series combination, the effective capacitance, so the charge it is equal, how we can find? The charge it is equal, charge is equal capacitance into potential. Okay, so what is the potential capacitance here? C effective, and potential it is 6 volts. So C effective, you have to find that. C effective it is equal, you have to write, that is 1 by, these are in series combination, 1 by CS it is equal, you can write that nothing but directly you have to write CS it is equal, CS it is equal C1 C2 by CS it is equal C1 C2 by C1 plus C2, right? C1 C2, 3 into 4 by 3 plus 4, it is equal 12 by 7 here, 12 by 7 microfarad. Okay, so the charge it is equal, Q it is equal C effective into potential. So 12 by 7 into how much here? 6 volts. Okay, 6 volts of charge potential. So now we can write that. So we have to take here 14 volts, and then here there is 14, right? So 7 2s are 14, and it is 12 2s are 24 microfarad. So charge on each capacitor, is equal 24 microfarad, 24 microfarad. So for the seeing of options, you have to choose easily. For suppose here there is a, what is that, 7 microfarad, 7 microfarad, B 24 microfarad, 24 microfarad, and C 8 microfarad, 9 microfarad, D 12 microfarad, 14 microfarad. So these are the options let us having. So in this series combination charge is same. So this is not correct and this is not correct. This is microcoulomb here. Microcoulomb. You have to find the microcoulomb. Right? Charge it is microcoulomb here. Okay. These are all the microcoulomb. So in the series combination the charge is same. So these are not same, these are not same, but this one and this one is same. So let us check. You have to, the answer it is in these two. So how we can find effective capacitance into voltage potential. So let us find the 24 microcoulombs. So this is the method you have to find in various circuits. If two condensers are connected, if two condensers are C and C by 2, C and C by 2 capacitances connected with V, connected with battery, potential V. What is the work done to fully charge the condenser. Okay, as shown. So the figure it is here. There is a two condensers C and C by 2. So here there is one of the condenser has C capacitance, another one it is C by 2 capacitance. Okay, these two are connected as shown in figure, and this is connected by the potential V. So then find what is the work done to fully charge. So the work done, it is nothing but the work done to complete the charge, it is nothing but stored in the form of energy, that is energy stored in a capacitor. So energy stored in a capacitor, it is nothing but U, it is equal of CV square. Because of I choose this equation, why? Because there is a capacitance are there and the potential V's are there. So hence we need to choose this option, this equation. Okay. So here the one more it is Q square by 2C and another it is QV by 2. So I can choose this one. Okay. So this is the effective capacitance here. The effective capacitance between these two capacitors. So these two capacitors, first end, second end. So these two are in parallel combination. So by the parallel combination, C effective it is equal, you can write that. So here the options are A 1 by 4 CV square, B 1 by 2 CV square, C 3 by 4 CV square, D 4 by 3 CV square. Okay. C effective it is equal C plus C by 2. C plus C by 2. It is 2C plus C by 2. It is equal 3C by 2. 3C by 2 here. This is the C effective. Right? The energy, the total work done to fully charge, it is the U, it is equal U effective. U, it is the 1 by 2 C V square. C, it is nothing but 1 by 2. C, it is nothing but 3C by 2 into V square here. 2 2s are 4. 3 by 4 C V square. So this is the energy. The work done should be stored in the form of energy. Hence we have to find that energy stored in the capacitor, that is 3 by 4 CV square. Where 3 by 4 CV square. So this is the option you have to choose. Right? Here the next question it is, here there is a capacitor 2, 3, 4 and 5 capacitors. Okay. Here there is a connection, here there is everything and there is here. This is point A, let it be point A and point B. Find equivalent capacitance between A and B. A and B. Each capacitance is C here. Each capacitance is C. So let us try it. So this is the previous model, we have to practice that. So here there is a point, let it be that there is a X and this is also a X. This is Y and this is Y. Because of from this point how much potential it has, and this is the point, the potential. This point how much it potential has, this is has potential. And redraw the diagram. So this is the A here and this is a capacitor as C, and coming to the X. Okay, between X and Y there is a capacitor. So here this is Y here, X and Y there is a capacitor C. And another, the second, this is the, for example 1, 2, 3, 4, 5 capacitors. The second capacitor is here, this is the second capacitor, and third capacitor is between Y and X. First end is Y, second end is X. So Y and X, so this is the capacitor which is connected to the Y. And fourth capacitor, that is nothing but X and Y. So X and Y here, right? So this is C. And the remaining last capacitor is here, this is point B here. So between X and Y, these three are in parallel combination. So the parallel combination, the effective capacitance it is, so here the read diagram, it is C and this is, the effective it is 3C. So this is one more capacitor having B, that is C. So these three are the capacitors here, which is in series combination. So where in series combination, C effectivity is equal, you can write that 1 by C effectivity is equal to 1 by C plus 1 by 3C plus 1 by C. 3C is the LCM, 3C. Okay, it is 3 plus 1 plus 3, it is 7 by 3C, 7 by 3C. Okay, 7 by 3C, it is 1 by C effective, C effective. Therefore C effective it is equal 3 by 7C, 3 by 7C. So this is the effective capacitance in this circuit. Clear? Very simple. Clearly you have to observe. So there is a connection is there. How much potential it has, that much of potential is there. And now this is one more connection here. How much potential it has, that much of potential is there. Between these 2 points, X and Y. So let it be X and Y are 0.1 or 0.2 or M and N, whatever that is. Okay, this is the effective capacitance. So these three are in parallel combination, then hence it is the resultant 3C. And C, 3C and C, these are series combination, you have to find this 7 by 3C. If you have to effective capacitance, find that 3 by 7C. Okay. So one more it is, there is a, that is the, here there is a circuit which is very complicated here. and here this is a another one, and one more. Here this is, right? How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So this is A and B. Find effective capacitance, effective capacitance between A and B. A and B. So you have to, at first you have to redraw the diagram. What you have to assume that. The redraw the diagram, it is the point here which is O. So this is the shape of a square, that is, and the origin, the center point, it is O. And here these two are connected. So this one and this one, these two are connected, and this one and this. And for example, here one first capacitor, second capacitor, third, 4, 5, 6, 7, 8. The third capacitor and fourth capacitors are in series combination because of this is the first end, the second end is connected to the first end of the fourth capacitor, and second end will be connected to the another capacitor. Similarly, fifth capacitor and sixth capacitor. So the read here we have to write the read diagram, which is, so here the capacitance, the point A, which is, here there are two capacitors at first, right? So this is the point B here. Okay, these are the two capacitors, and one more capacitor, that is, this is the capacitor, and this is another capacitor which is connected point B. Okay, and another, it is the, these are the two capacitors, and here which are connected point B. So this 7 and 8, this is 7 and 8, this is 3 and 4, this is 1 and 2, and one more, it is 5 and 6. So this is the center point, that is O. So here this is the capacitor and capacitor which is connected. This is 5 and 6, and this is center point O. So here let us see the two capacitors. These are in series, CS. These are in series, series. So four capacitors or four pairs are in series, and series combination CS, it is equal C by 2 here. 1 by C plus 1 by C, it is equal C by 2. Here also C by 2, right? Here also it is equal C by 2. It is equal C by 2. It is equal C by 2. The effective capacitance. So these four C by 2s are in parallel combination, right? So in the parallel combination, Cp, it is equal, that is equal C by 2 plus C by 2 plus C by 2 plus C by 2. It is equal 4 C by 2, right? It is how much? 2C. The effective capacitance, C effective, it is equal 2C here. C effective, it is equal to 2C. Clear? See once, these two capacitors and these two capacitors. For these two capacitors, this end is this one, and this end is connected to this capacitor, and this end is this one. So by the dividing of the center point, so this is the center, these are the two pairs, and these are the two pairs, right? So there are four series are there. This is the one of the series, one of the series, one of the series, another one. So the series combination is C by 2, C by 2, C by 2, C by 2. These are all in parallel combination. So hence we can find that 4C by 2, it is nothing but 2C. So this is the effective capacitance in this circuit. Clear? This is the method you have to find the resultant capacitance or equivalent capacitance in different circuits. In our next session, we have to practice the more numericals of circuits, that is nothing but which is complicated circuits, that is symmetry of circuits, and the complicated blades of connected, okay, and infinite connecting capacitors, Okay, and switch type of capacitors. So these models will be explaining in our next class. If you like this video, please share to your friends, and do not forget to subscribe. Thank you, Ananda. Examinations and very interesting circuit here. So very important model also. So the connection, the arrangement of capacitors are in spherical manner. It is circular manner. So here this is point N and this is point M here, where there is a capacitor here having capacity C, and one more capacitor is here, another capacitor, and here capacitor. So each capacitor has the capacitance C here. Like find the effective capacitance, or equivalent capacitance, effective capacitance, okay, between M and N. So let's see. So here there is a point, let it be P here. So we can simplify the circuit, that is redrawn the circuit. That will be how we can redrawn this. So this is M. So also this can be M and this can be M. Clear? Because of here there is no any devices are connecting there. There is no devices are connecting. That's why how much potential it has, that much of potential is there, that much of potential is there. But here there is a capacitor, and similarly see here there is N potential, and also here there is N potential. Right? That is the first point. You have to solve this type of questions. Right? So now we have to marking the point M here, and which is nothing but P here, that is P, and also one more point, that is N here, N. So let's see the diagram. In the circuit from M to P there is a capacitor. From M to P there is a capacitor. Let it be, write the capacitor here, M to P. And one more capacitor is there, this capacitor, this is completed. And one more capacitor P to M. So P to M is also one capacitor here, P to M. Right? So this capacitor is also completed. And one more capacitor from N to M or M to N. So this is the capacitor which is N to M here. Clear? This was also completed. The remaining capacitor is this one. So this capacitor is between N to P or P to N. So P to N there is a capacitor here. Clear? How we can run this? See once. From M to P, between M to P there is a capacitor. Between M to P there is a capacitor. And between P to M there is another capacitor having the capacity C. Right? These two are completed. And one more capacitor is N to M. So one more capacitor is N to M. So this is the capacity C here. And the remaining capacitor is P to N or N to P. So N to P or P to M. So this is another capacitor. So now it is easy to calculate this one. How we can calculate? These two are in parallel combination. At first these two are in parallel combination. The parallel combination of this effective capacitance is C plus C, it is equal to C. So now this is M, right? Here this is 2C and this is point P, okay? And here there is a capacitor C and here there is point N. The other capacitor is there, that is N here. Clear? This is C. Now these two are in series combination. These two capacitors are in series. So here these two The effectivity is C effectivity is equal C1 plus C2. So this is equal C plus C, it is equal to 2C. This 2C capacitor and C capacitor, 2C capacitor and C capacitor will be series combination. From these two, 2C and C are series, are in series. Hence 1 by or C effective, you can write that C effective it is equal C1 C2 by C1 plus C2. Let it be write as 2C into C by 2C into C by 2C plus C here. Okay. Let how we can find that. It is equal 2C square by 3C. C and C cancelled out. It is 2 by 3C. So this is the C effective. C effective here. So here the next circuit it is, this is point M here, and here the capacitor it is 2 by 3C, and this is point N, and there is a one more capacitor having C here, right? Now these two capacitors are in parallel combination. How we can find that? So these two are in parallel, therefore CMN it is equal 2 by 3C plus C. 2 by 3C plus C. So that is equal CMN it is equal 2 by 3C plus C, it is equal 2C plus 3C by 3. It is equal 5 by 3C. So this is the effective capacitance between M and N. 5 by 3C. This is the answer here. So C effective it is equal 5 by 3C. So this is the answer here. Clear? Very simple method here. So let the simple we have to choose at where the potential is there. That should be the point you have to first you have to select. Okay. So if there is a M point, there may be an M, and if it is N, it has N. So the point, center point is, let it be P. So between M and P, so these are the 3 points we have to choose in M, P, N. Between M and P there are 2 capacitors are there, M and P, P and M. So there are 2 capacitors are drawn. Clear? And P to N. So here P to N is there one capacitor, and M to N or N to M, N to M or M to M. So this is another. From this we can calculate easily, that is 5 by 3C. Okay. And see one more example. One more complicated circuits. So which are frequently asked in JEE mains and NEET examinations. So this is the blades of the capacitors are given. The blades of the capacitors. So these are the blades of the capacitor, and the first blade and the third blade is connected, and the second blade and the fourth blade is connected, right? So this is point A here, and this is point B here. Okay, find effective capacitance between A and B. Find the effective capacitance between A and B. So this is the, they can be asking only the circuit and find the capacitance between A and B. Okay, how we can find this? Right. So this is the simple method which we have to follow. That is the easy trick which I can be told here. So that is, if first you have to calculate, count the number of plates here. 1, 2, 3, 4. How many plates are there? There are 4 plates are there, right? Between first plate and second plate there is a capacitor C1, and the second plate and third plate, between second and third plate there is a capacitor having capacity C2, and between third and fourth plate there is a capacitor having C3 capacitance, right? There are 3 capacitors are there. So now at first you have to point out at point A, the point A is connected by the how many plates, which plates they are connected, that is first plate and third plate, first plate and third plate. So this is the first plate and this is the third plate, they are connected to each other. And coming to the point B, the point B is connected to second plate and to the fourth plate, second plate and to the fourth plate. Right? This is the first step you have to do. And between the capacitor C1 is between first and second plates. This is first and this is second. So here you have to run capacitor C1, first capacitor. And capacitor C2 is between 2 and 3. This is 2 and this is 3. So here there is a capacitor between 2 and 3. So this is 2 and this is 3. This is the capacitor, right? And third capacitor between 3 and 4. This is 3 and this is 4. This is 3 and this is 4. Clear? So now we are seeing this circuit. These three capacitors are in parallel combination. So here in the question here, each capacitance is C. Options 3C, 5C, 2C, C. Okay, let us see. So if these three capacitors are in parallel connection, so then the effective capacitance C effective it is equal C plus C plus C, because of each capacitance is C. This is C, this is C, this is C. Okay, C plus C1 plus C2 plus C3. C plus C plus C, that is equal to 3C. Okay, right? The answer it is 3C here. This is the answer. First, suppose if the gaps between every plate, let gap the distance between each plate. Distance between each plate is D. So this is D and this D. D. Then capacitance C is equal to epsilon naught A by D. The resultant capacitance between parallel plate capacitor. So epsilon naught A by D. So then the effective capacitance it is equal 3 into epsilon naught A by D here, because of C is equal epsilon naught A by D. So then the answer it is, if there is an answer, maybe asking in this term also 3 epsilon naught A by D or 3C. Okay, so in this method you have to observe carefully how many plates are there and the capacitor which plates are connected. So at point A 1 and 3 plates are connected. At point B 2 and 4 plates are connected. So from these, between these two, how many capacitors are there? Let's draw a read diagram. Hence you have to get the answer easily. Okay. Here these are the plates of a capacitor. How many plates are there? 1, 2, 3, 4, 5. So first plate and the third plate, and the second plate and to the fifth plate. Second and fifth plates are connected. So this is point A here and this is point B here. Okay, find effective capacitance CAB and each capacitance is C. Each capacitance is C. Options are, it is 2 by 5C, B 5 by 2C, C 3 by 2C, D 2 by 3C. So let's see how we can find this very important model. So at first what you have to do this, at first we have to given the number of plates 2, 3, 4, 5. 5 plates are there. Okay. first plate, between the first and second plate there is a capacitor. What is that? C1 here. And 2 and between 2 and 3 there is capacitor C2. Between 3 and 4 there is capacitor C3. 4 and 5 there is capacitor C4. 4 capacitors are there, that is C1, C2, C3 and C4. Of course, the C1, C2, C3 and C4 also is equal to the capacitance C. Right. At first we have to point out a point A. So at point A, which plates are connected? First plate and third plate. So we have to write first and third plate. At point B, which plates are connected? Second and fifth plate. Second and 5. Clear? And now what you have to do? So what are the capacitors are connected between these two plates? Let us see. The first capacitor C1 is connected between 1 and 2. So this is 1 and this is 2. Here clearly you have to draw a capacitor here between 1 and 2. Coming to the second capacitor. So this is C1 let. C2 capacitor, that is nothing but 2 between 2 and 3. So this is 2 and this is 3. So here there is a capacitor between 2 and 3. 2 and 3 there is a capacitor C2. Coming to the C3 capacitor. Coming to the C3 capacitor between 3 and 4. So this is 3. There is no 4 here. So there is a fourth point. Between 3 and 4 there is a capacitor. There is a capacitor C3. Here the another capacitor is there C4, that is 4 and between 5. So this is 4 and this is 5 here. So between these two a capacitor. This is C4. Simple. Clear? Okay. Let us see one more time. At first you have to draw point A. Which plates are connected? First plate and third plate. Right? This is first plate and this is third plate. These are connected to each other. First and third plate. And coming to the point B. Which plates are connected? Second plate and fifth plate. So this is 2, 5. Right? So now seeing the capacitor C1. Capacitor C1 is between 1 and 2. So this is 1 and this is 2. Here there is a capacitor C1 here. So this is C1. Okay. And the capacitor C2 is between 2 and 3. So this is 2 and this is 3. So here there is a capacitor between 2 and 3 here. This is C2. Now capacitor C3 is between 3 and 4. This is 3 but there is no 4. Let there is a 4 here, fourth point, and here there is a capacitor. That is C3 here. And one more capacitor C4 is 4 to 5, between 4 to 5. This is 5 and this is 4. There is a capacitor, it is C4. This is the simple circuit you have to simplify. Redraw the circuit. Okay. Now we have to easily calculate this circuit. So these two capacitors are in series combination. These two capacitors are in series combination. So each capacitor having the C. So let us series combination of CS, it is equal C1 C2 by C into C by C1 plus C2. C1 plus C2. It is C square by 2C. It is C by 2. The series combination, it is C by 2. Now we have to redraw this circuit, that this is A, and here there is a capacitor. Okay, here there is a capacitor and this is B, and there is a capacitor which is C by 2 here. This is C, and here there is capacitor which is C here. Right? This is C. This is C by 2 and this is C. Each capacitance is C. Okay. For these three are looks like parallel combination. For the parallel combination, C effect it is equal how much? C plus C by 2 plus C. C1 plus C2 plus C3. C plus C by 2 plus C. Here 2 is the LCM. It is 2C and plus C and plus 2C. It is how much? 5 by 2C. So this is the C effective. C effective it is 5 by 2 C here. Clear? So this is the method we have to find very easily. So where it is 5 by 2 C is the right option here. 5 by 2 C. So if the gaps between all the capacitors are given that there is a D, then the capacitance C it is equal epsilon naught A by D. Hence you can write that it is C effective it is equal 5 by 2 epsilon naught A by D here. So this is the effective capacitance, right? So this is the one of the important, very important method you have to find the effective capacitance. Let's see one more example. There is a blades of a capacitor. How many blades are there? 4 blades are there. The first blade and to the fourth blade is connected to each other, that is point A, and the second blade and third blade is connected to each other, that is point B. Find effective capacitance. Effective capacitance between A and B. Between A and B. Right. How we can solve this? Trying for it. Please try, all of you. So at first you have to given the number of plates 1, 2, 3, 4, right? And here there is a capacitor between first plate and second plate C1, second plate and third plate there is capacitor C2, third plate and fourth plate there is capacitor C3. 3 capacitors are there. So now let us point out point A is connected between 1 and 4, 1 comma 4. Point B is connected between 2 comma 3, 2 comma 3 here. The first capacitor C1 is connected between 1 and 2. So this is 1, this is 2. So here there is a capacitor 1 and 2, right? And between 2 and 3, between 2 and 3 there is a capacitor. This is 2 and this is 3. Okay? The two ends of the capacitors are connected. Two ends of the capacitors are connected. So this is a capacitor. The two ends of the capacitor may be connected. It is. So this is the connection. So here there is no. This is not a capacitor. Okay. So here 2 and 3 end. So these two are the ends of the capacitor. Two ends are both the two ends are connected at single point. So this is first end, this is second end. These two ends are connected, and then this is not a capacitor. So this may not be working here. This is the very, very important point you have to remember. The C2 capacitor is not working. That is not a capacitor. And coming to the C3 capacitor between 3 and 4. This is 3 and this is 4. So here there is a capacitor here, right? For these two are parallel to each other. So each capacitance C. Each capacitance C, then C and C are parallel. Therefore C effective is equal C plus C it is equal to 2C. So this is the effective capacitance. So here one more important point you have to remember that if two ends of a capacitor are connected at the same point, it means what is that here? Two alter points. For example, if there may be these 2 points are connected, this is not a capacitor. If these 2 points are connected, this is not a capacitor. Okay. So that's why the two ends of the capacitor is connected. The two alternate connect the two order of capacitors. So this is the example. This is the ends of capacitor. This end and this end. This cannot be connected. Will not be connecting each other, right? So these are connected to the another capacitor. But here there is no other capacitor. They are connected to each other. So hence it is not a capacitor. So this is not working here. So the two capacitors only here. So that is the main point you have to remember here. The effective capacitance it is 2C. Okay. So very, very important model this one. Let's see one more example here. There are a capacitor plates. 1, 2, 3, 4, 5, 6, 7, 8, and one more 9 plates. Okay. So here the second plate and to the fourth plate. Second plate and to the fifth plate, and the fourth plate and to the eighth plate. So here this is the point A and there is point B. Now find the equivalent capacitance. Now find equivalent capacitance. Equivalent length capacitance, okay, between A and B. Each capacitance C. Each capacitance C here. Okay, let us see. Here there is a capacitor as C1, there is capacitor C2, C3, C4, C5, C6, C7, C8. 8 capacitors are there, 9 gaps and 8 capacitors are there left. So let us draw point A, which is connected point A 2 and 5. 2 and 5. And there is a point B. Point B is connected between 4 and 8. 4 and 8. Right? So now let us redraw the circuit here. The capacitor C1 is connected between 2 and 1. So there is no 1 point. There is no 1. So here there is a 1 here. Let there is a 1. Okay. And second plate and third plate, between second and third, here there is no third. Let this is the third capacitor here. Between third and fourth, another capacitor there. So this is third and fourth. So this is fourth here. Okay. And 4 and 5, there is a capacitor C4. This is 4 and this is 5. There is a capacitor 4 and 5. And this 5 and 6. So this is 5. Okay. There is no 6, and you have to draw. This is the point 6 here. Okay. And 6 and 7, there is a capacitor. 6 and 7. So this is 7 here. There is a capacitor 7 and 8. 7 and 8. There is a 7 and 8. Between 7 and 8, there is a capacitor. 7 and 8. So this is the capacitor. Okay. 7 and 8 means between 7 and 8. Here there is a 6 and 7. Between 6 and 7 there is a capacitor. It is 7th point. 7 and 8 there is a capacitor. It connected to the 8th point. Okay. And 8 and 9. 8 and 9 there is a capacitor. Here the point it is 9 here. Clear? So this is the connection. You have to redraw this diagram. How we can run this? Okay. Let's check once. So to point A, it is connected to the second plate and fifth plate. So this is second plate and this is fifth plate. Point B is connected fourth plate and eighth plate. So this is fourth plate and this is eighth plate. Okay. And now coming to the first capacitor, that is C1 capacitor. C1 capacitor, it is between 1 and 2. So this is 1 and this is 2. Okay. This is the capacitor C1. C2 capacitor between 2 and 3. Between 2 and 3. Between 2 and 3 there is a capacitor. Between 3 and 4. 3 and 4. So this is 3 and this is 4. There is a capacitor. And 4 and 5 there is a capacitor. This is 4 and this is 5. There is a capacitor. And 5 and 6. So 5 and 6. This is 5. There is no 6. You have to draw here. This is 6. There is a capacitor. 6 and 7 there is a capacitor. 6 and 7 there is a capacitor. 7 and 8. 7 and 8, between them there is a capacitor. Clear. 8 and 9. This is 8. There is no 9. Here there is a 9. So here these two are not connected to any one. So this is not a capacitor and this is not a capacitor. Simple. Okay. Understood? So this is not a capacitor. This is not connected by anyone, and this is not connected by anyone. So hence these two are not capacitors. So now let's see. So this is capacitor having C, capacitance, and here capacitance C. Okay. And one more. It is capacitance C and C. Here C, C, C. How many capacitors are there? So these three are in series, these two are in series, this is in series. So these three are in parallel combination. This is not working, this is not working. The simple diagram it is. How we can run this? It is equal to, this is point A, and here there is, these three are in series, C and C and C. So it is in series combination, that is, what is that? 3 by C, it is C by 3. Okay, this is the point B. And one more, these two are in series, that is the capacitor. Series combination is C by 2. Okay, and this is the C. So here this is the C, and now these three are in parallel combination. These three are in parallel combination. So the effect of capacitance in parallel combination, so that is equal to C, it is equal C1 plus C2 plus C3, C by 3 plus C by 2 plus C. 6 is the LCM. 6 is the LCM here. And 2C plus 3C plus 6C. It is equal to 5C plus 11C, 11 by 6C. So this is the effective capacitance. 11 by 6C. That is the effective capacitance. Clear? So this is the method you have to find. So let us see one more time how we can run this Ree diagram. So here there are 9 plates are there, and second plate and fifth plate are connected point A, fourth plate and eighth plate connected point B. So there are 8 capacitors are there between the 9 plates. Okay. So at first we have to point out point A. How many, which points are connected? Second plate and the fifth plate. And let point B here, which point it is, where B it is the fourth plate and eighth plate. Fourth and eighth plate. Okay. Now let's see. So the first capacitor, C1 capacitor. C1 capacitor is connected between 1 and 2. So here there is no 1. There is no 1. There is a 2. So here you have to let there is a point 1. Okay. And coming to the second capacitor. Second capacitor is between 2 and 3. This is 2. There is no 3. Let there is a point 3. This is the capacitor 3. Point 3. Between 3 and 4. Between 3 and 4 there is a capacitor. Between 3 and 4. This is the 4. And here there is a capacitor connected. Okay. And now 4 and 5. Between 4 and 5 there is a capacitor C4. This is 4 and this is 5. So this is a capacitor. And between 5 and 6, between fifth plate and sixth plate, fifth plate and sixth plate, there is a capacitor. So this is the fifth plate, there is no sixth plate. Hence, this is the sixth plate. Okay? And sixth and seventh, between there is a capacitor. There is no seventh plate. Here, this is the capacitor having 7. And between 7 and 8 there is a capacitor. This is the 8. So this is a capacitor between this one. Okay. And 8 and 9 there is a capacitor. This is 8. There is no 9. Hence we have to draw this one. This is the 9. Here this capacitor is not connected by the anyone, hence it is not a capacitor. So this is also not connected by anyone, hence this is not a capacitor. Hence we have to check these three are in series combination by the series combination C, C, C. So how we can find this? 1 by C it is equal, 1 by C effective it is equal 1 by C plus 1 by C plus 1 by C. It is equal, C is LCM 1 plus 1. It is equal 3 by C. It is nothing but C effective it is equal C by 3 here. Okay. So this is C by 3. These two are in series combination. This is C and this is C. If two capacitors are in series, C effective it is equal, right, 1 by C plus 1 by C. It is equal, C is LCM 1 plus 1. It is equal 2 by C, where C effective it is equal C by 2. So this is the C by 2 capacitor. And this is C. This is C. Hence this can be redrawn. This is point A and this is a capacitor. This is point B. This is the C by 3 and this is the C by 2 and this is the C. Okay. So now these three are connected in parallel. So in parallel combination, C effective it is equal C1 plus C2 plus C3. It is equal, 6 is LCM here, where it is 2C plus it is 3C and plus 6C. It is equal 11 by 6C. So this is the effective capacitance here. Clear? So this is the method we have to find the effective capacitance between the blades of a capacitor. Very simple. The capacitor plates. So this is the second plate and this is the third plate. First plate, second plate, third plate, fourth plate. This is A and this is B. Right? Find the effective capacitance. Find the effective capacitance of each capacitance C. Okay? Right. So here this is the variety model which you are not seeing before. Okay? So similarly, at first you have to choose the point A and the point B. So the point A is connected at second plate, the point B is connected at third plate. Here 1, 4. 1, 4 is there. 1, 4 is between what is that? 2 and 3. 2 and 3. This is the point you have to remember. Right? So here there is a point, choose, that is 1, 4 between A and B, 2 and 3. Between 2 and 3 there is 1, 4. Right? So first plate, so this is the capacitor C1, C2, C3. 3 capacitors are there. First capacitor C1 it is between 1 and 2. So 2 and 1 there is a capacitor. This is the 1. And 2 and 3 there is a capacitor. 2 and 3 there is a capacitor. And 3 and 4 there is a capacitor. So 3 and 4 there is a capacitor. Clear? This is C and C and C. These two are in series. These two are in series. The series combination CSCT is equal here C by 2. So therefore C by 2, and here this is A, this is C by 2, and this is B, and this is a capacitor C. C by 2 and C are parallel combination. The C effectivity is equal C by 2 plus C. It is equal 3C by 2. So this is the effective capacitance. C effective. It is 3C by 2. Clear? Don't confuse. So here 1, 4 are between 2 and 3. Let it be 1, 4 is between 2 and 3. So this is the 2 and 3. Between them there is 1, 4. So between 1 and 2 there is a capacitor. Right? Between 2 and 3 there is a capacitor. Between 4 and 3, 3 and 4, there is a capacitor C3. From this diagram, you can easily calculate that the effective capacitance, it is 3C by 2 here. So one more example, the last example you have to see, that is, here there is a circuit which can be having, this is the circuit here. Here this is the circuit. So here there is a capacitor, there is a capacitor, and there is capacitor, capacitor, here a capacitor. Okay. Here there is a capacitor. So this is point B and this is point A. Find the equivalent capacitance between A and B. Find the equivalent capacitance between A and B. Here each capacitance having C and C. Each capacitance is having C. So let us see, this point is B and this may be a B. This point is A, this point is also A here. So how we can run this? Between point A and point B. Okay? How we can run this? So this is second and first and second and second end. So this is the parallel combination. From this there is a parallel combination of two capacitors, this one and this one. Here this is the parallel combination, this capacitor and this capacitor. Okay, for A. And for coming to the B, so this is the first end, second end. So these two are connected. This is also a parallel combination. At first we have to see this type of connection in the starting of our video. So let us check once. So this is a parallel combination. Here there is a two capacitors having in parallel. Right? So there is one more, so this one and this one and this one will be completed. So this capacitor and this capacitor is there. Here one more capacitor which is connected between A and B. So this is the capacitor. And here one more capacitor which is connected between A and B. This is the capacitor. Okay, this capacitor and this capacitor. Between two parallel capacitors. Okay, now these two capacitors C and C and C, 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 these two are in parallel, right? These two are in parallel combination, that is 2C. These two are in parallel, that is 2C. C plus C, 2C, C plus 2, C. So this is the one more rearrangement of the circuit, that is here point A. Okay, the circuit, how we can run this? This is point A, which is connected. So this is the 2C and this is the C here, right? And this is a, so right, so this is point A and this is the point B here. And here there is, that is C, and there is 2C. Here this is the arrangement. From this, these two are in series, these two are in series and these two are in series. By the series combination 2C and C. What is that? Series combination CS, it is equal, C8 is equal 2C into C by 2C plus C. It is equal 2C square by 3C. It is equal square, C will be cancelled. 2C by 3 here, 2 by 3C. Here there is a capacitor. The rearrangement of the circuit, it is, here there is a capacitor which is, it is B, and here there is a capacitor which is here. This is also 2 by 3C, 2 by 3C in 2 by 3C. So these two are in parallel. Now these two are in parallel. How we can calculate this? So C effective, it is equal 2 by 3 C plus 2 by 3 C. Okay, so 3 is LCM and 2C plus 2c by 3, it is equal 4c by 3, 4 by 3c. So this is the C effective, right? So this is the very complicated circuits which you have to thinking logically. So this is the very important models you have to practice. Okay. So students, these are the very commonly asking in JEE mains and NEET examinations. So if you have to practice thoroughly, and you will get definitely you can solve within a short time, you will be get answer. And this is our video. If you like this video, please subscribe my channel and share to your friends. If you have any doubt, please ask me in the comment section. Thank you one and all.